we move to the next topic, time complexity and space complexity. Whenever we write a program, then we ask two questions. How much time does the program take to execute? And how much memory does the program use? The first question is how much time does the program take to execute, and how much memory does the program use? These two questions are helped to decide whether the algorithm efficient or not. Then today we will learn how to measure the time and memory used by an algorithm. So we move to the topic time complexity and space complexity. Then, whenever we analyze an algorithm, we mainly consider two factors. First is time complexity, second is space complexity. Time complexity means it tells us how much execution time of an algorithm needed, and the second space complexity, then it tells us how much memory an algorithm need. These two measures help us compare different algorithm and choose the better one based on the time complexity and space complexity. In these two measurements, we help to compare different algorithms and choose the better one. Suppose there are two students, both solve the same problem, then student A finish 2 minutes and student B finish in 5 minutes. Who is better? Student A is better because it only take 2 minutes. Now suppose both students finish in 2 minutes, but student A uses only one notebook, then student B uses 5 notebook. Who is better one? Student A is better because it is only use less memory space. So in algorithm we compare both time and memory. Okay. Then first we start with the time complexity. The time complexity tell us how much time algorithm take the input size increases. It does not mean actual second, it means how the running time grows when the number of input become large. This means time complexity means how the running time grows when the number of input become large. For example, there are algorithm read read n, then print hello, stop. There are a algorithm read n, print hello, stop. Then how many time the print statement executed? Okay, one time. Yes, correct, one time. So the execution time never change. Whether the n is 100 or 10,000, the statements is still executed only once. So the time complexity is order of 1. Here order of 1 means what? Constant time. Then move to the next example. For an example, you ask you to switch on the classroom. Okay, switch on the classroom light. So how many operation are needed? Only one operation are needed. So switch on a light is a example of order of 1 because it is constant. Next example is linear time complexity. For we look another example. For I equal to 1, I less than n, I plus plus, then print I. Then how many times does the loop execute? N times. Okay, n is 5, the loop execute 5 times. The n is 100, execute it 100 times. So the execution time increase with n. Then the time complexity is what? Order of n, because it execute increase with time increase with n. So the time complexity is order of n. This is called linear time complexity. Then next we move to the another example, quadratic time complexity example. For now there are program for I equal to 1, I less than n, I plus plus. Then for j equal to 1, j less than n, j plus plus, print I j. So in this program we use two loops. How many loops are there? Two. Then each loop run n times. So total execution are n into n times. That means n square. So the time complexity is what? Order of n square. This is called quadratic time complexity. So first of all, we discussed what is time complexity. The time complexity tells how much time an algorithm take the input size increase. It means how the running time grows when the number of input become large. Then we example with the simple example constant time example. That means read n is equal to read n and print hello example. It is the complexity word order of 1. Then we move to the linear time example. For I equal to 1, I less than n, I plus plus print I. Then we use the n times execution. So the time complexity is what? Order of n. Then we move to the next example, quadratic time example. Then in this example we use the two loops. Then each loop run n times, so it have two loops. Then n into n is equal to n square. The time complexity is what? Order of n square. This is called quadratic time complexity. Then we move to the common time complexities. We already discussed in previous sections. Then type of time complexities. There are three type of time complexities: best case, average case, worst case. Then best case means the minimum. Best case means what? The minimum take by an algorithm. That means the minimum time taken by an algorithm is best case. Example, linear search, because the first element is the answer, only one comparison is needed. So complexity is what? Order of 1. Then average case means what? In the accepted time for a normal input. That means average time, the accepted time for a typical input or normal input. This is means average case. The for example complexity is what? Order of n. Then next one is worst case. What do you mean by worst case? The maximum time taken. For example, if the element is last one, we check every element. So it take the maximum time. Then the complexity is what? Order of n. This is the three type of time complexities: best case, average case, worst case. Best case means what? The minimum time taken by an algorithm. Average case means the expected time for a normal input or a typical input. Then worst case what? The maximum time taken. These are the three type of time complexities. Then we move to the next complexity, space complexity. Now let us study the space complexity. What is space complexity? Space complexity tells us the how much memory an algorithm requires during execution, or the total amount of memory required by an algorithm during the execution. It also includes memory used for variables, arrays and temporary storages, etc. Okay, it also include memory used for variables, input space, auxiliary spaces, that means temporary storage, arrays, etc. So in this formula, the space complexity means what? Fixed part plus variable part. Fixed part plus variable part. The space complexity equal to fixed part plus variable part. This is the space complexity formula. For example, int a, b, sum. Then only three variables are used. The memory is fixed. So the space complexity is what? Order of 1. Three variables are used, a, b, sum. Then memory is fixed. So space complexity is what? Constant. Then move to the next example. Int array of n. The array says depend on n. If n increase, the memory also increase. So the space complexity is what? Order of n based on the n. So n increase, the memory also increase. So the space complexity is what? Order of n. Then this is the examples of space complexity. What is space complexity? Space complexity is means how much memory an algorithm required during the execution. This is called space complexity. We also have a space complexity formula. A space complexity formula means what? Space complexity equal to fixed part plus variable part. Then we already discussed two example, int a, b sum example and int array of n example. Then components of space complexity, it have two components. First one is fixed part, second one is variable part. The fixed part means contain variables, constants, program instructions, etc. The memory does not depend on input size, that the part is called fixed part. Then variable part is array, dynamic memory, recursion stack, etc. That means memory that change with the input size. That part is called what? Variable part. This is the components of the space complexity. This space complexity means what? Fixed part plus variable part. Okay. Then differentiate between time complexity and space complexity. This is the one of the important exam questions. So move to the difference between time complexity and space complexity. Time complexity means measures execution time. Then space complexity measures memory usage. Then time complexity related to speed and space complexity related to storage. Then represent using big O notation, and the space complexity represent using big O notations. Also order of example, order of n square. Another example of space complexity is order of n. So the importance of time complexity is help choose faster algorithm, reduce execution time, improve the performance. Then space complexity importance means help optimize the memory usage, important in memory limited system, and improve the resource management. Then in this section today we learned two important concepts: time complexity and how much execution time algorithm needed. Then space complexity tell us how much memory algorithm needed. Then we already also study the constant and linear and quadratic time complexities and three cases of time complexities and the difference between time and space complexities. Okay.